Hello, everyone. So welcome again to Distilogix webinars and trainings. We're happy to have you as always. And we're going to wait a bit for people to join, and then we will start this training and webinar by a short video to introduce Asterfusion to you guys. And then we will pass it to the gurus and geniuses we have here, Sean and Ivy from Asterfusion. So 30 seconds of silence until people start joining, then we will play our video and we will start the activity. Thank you so much for being with us today. I think we can start our video, our introduction video, and then we will continue with the webinar agenda. Let me just about the video. Let me know if you cannot hear it. You should be hearing the audio too. Great. Thank you so much for such a good introductory video. So open networking, and today it's probably one of the largest topics in our industry. And the reason behind that is that all public cloud providers and the largest data centers in the world today, they use open networking. I'm sure you know that, or you expect at least that Alibaba or Google Cloud or AWS, they do not use traditional switches that we know. So they all depend on open networking because of the high technology, low latency, and they enjoy the power of SONiC, the operating system that is the star of today, software of open networks in the cloud. Our technology partner today is Asterfusion. Asterfusion is a leading manufacturer of open networking switches. And actually, they do everything. They do the bare metal switches that you can take and program the way you want, and they do open networking, and they can give you, wide switches, and they can give you, where they give you the power of their enterprise version of SONiC, and also they give you other options too for programmable switch servers and others. I'm not gonna take longer than that. I'd like to introduce to you, we have Miss Ivy, who is responsible for the sales of Asterfusion in our region in the Middle East and Africa. So welcome, Ivy. We're happy to have you with us. Thank you for your support.
Hello, hi all. This is Ivy. Nice to meet you.
Great, thank you so much. And we have our expert, Sean, from Asterfusion, and he's from the systems team, and he will be our main presenter. Today, we would like to have it a very open discussion. We have selected you guys on purpose because we know of your interest in this topic and the value that it can add to your business and to your customers. So I really would like to have it an open discussion. We have a small group today. Consider it as a meeting, not a webinar. Be very interactive. Sean loves to answer questions, so please have your questions. If you want to post them in chat or Q&A, or if you want to talk directly to Sean, I can let you talk, and then we have an open dialogue. Asterfusion does everything: campus networking, data center, where they did a great job because of their lowest latency on earth. And that's why cloud providers, they use them, but they also do a lot in campus networking and wireless. I think Sean will start with the campus networking, but we're ready to talk about everything that you guys have. Sean, to you, buddy, thank you so much for your support to our region.
Yeah, thanks, Muhat. So now let me share my screen and okay. You can see my screen now, right?
Yes, I can.
Okay. Hi, everyone. This is Sean from Asterfusion. Thanks, Muhat, for this webinar or meeting. We have been collaborated with each other for 1 year. Thanks again for your efforts to promote our brand. Today, I want to talk about our products and solutions and share our ideas about the future of open networking. In the past 10 or 20 years, we are finding that the digital products we use every day are becoming less and less, like telephone, camera, MP3 players, GPS. The dedicated devices are replaced by smartphones, and Android is playing the role as a standardized platform to hold all these functions. The similar changing is also happening in IT industry, servers, storage, and also in networking. What we are doing is to participating in the open networking ecosystem. Currently in the market, traditional network device vendors, they are providing bigger and bigger chassis and their own operating system implementations, which binds the customers to their destiny. Things will be changed when the ecosystem becomes open. The products will be divided into 4 parts: standard hardware, ASIC enabler, network operating system, and applications. So that users can even join the ecosystem by developing their own applications based on their own demands. There will be no complicated hardware implementation and vendor locking. Sonic is an important project funded by Microsoft, aiming to build a standard architecture of network operating system, which can run on any standard hardware. Hyperscale cloud, we can see in this picture, the hyperscale cloud providers like Alibaba and Google, ASIC vendors like Broadcom and Marvell, and also some traditional vendors like Cisco and Dell. All of them are contributing to Sonic. We are also one of the members of Sonic Foundation. Asterfusion has 3 core technologies as a contributor of open networking. The first one is our distributed algorithms. Traditional hardware architecture increases the scalability based on device backplane capacity. But when the throughput becomes to TB or even PB, the hardware will be limited by complexity and capacity. CLOS architecture changed the network topology. All box switches can be used in different layers like leaf, spine, and fabric spine to build a multi-layer closed network. The scalability of the single fabric is potential to be expanded without any hardware limitation. The distributed algorithms are used to manage the fabric network. As the fabric scale out to hundreds of switches, fabric controller can manage the entire fabric network as a single virtual device. Is there any question? Oh, okay. The second core technology is our cloud-native multi-chip adapted network operating system, AsterNOS. Different from traditional network operating system, AsterNOS uses a containerized architecture with Redis DB as a pivot of all the containers. Applications can be easily installed as a container based on customers' demand, and AsterNOS will finish the underlying adaptation to different ASIC vendors. The third technology is high-density, high-speed board designing and manufacturing process. Different from some other vendors, we have our own hardware production line, including designing and manufacturing. Currently, we have 12.8T hardware with 32 400 gig ports or 64 200 gig ports. As the requirements from the market grow, we will have 25.6T or even 51.2T hardware in the future. This page shows our product portfolio. At the bottom right, you can see we have various hardware platforms. At the left side is AsterNOS, which is based on Sonic, and our cloud network controller, AFC. Based on the hardware and software, we have many different product lines like Cloud Fabric, Campus Access, Packet Broker, programmable bare metal, and some DPU appliance. The data center switches, we call it the Cloud Fabric product line, currently has 4 different models with 48 25 gig downlink, 32 100 gig, 64 200 gig, and 32 400 gig. The switching capacity is from 2 Tbps to 12.8. CXN series switches are using mobile Teralink switch chip for ultra-low latency, and they can support in-band telemetry for better monitoring and maintenance experience.
So Sean, these are like best positioned for the spine of the network, right?
Actually, both spine and leaf. We can see in this topology, we recommend to use CX3N to act the role as a leaf, and like 532 as a spine, or we can use 532 to build a entire spine leaf architecture with just one model.
Okay, great. Because both have really huge switching capacity and low latency. So yeah, they fit both spine and leaf designs. And you guys, as you know, spine and leaf is the replacement of the old 3-tier networking model, which is the dying model. It's a much more efficient and scalable model of building your data centers and connecting your network devices. Go ahead, please, Sean. Sorry to interrupt. Apologies.
Yeah, it's okay. Yeah, because now as our considering 10G server access server is less and less. Now the mainstream is 25G, or even some big companies is already using 100G access server, and even in some HPC or AI based projects, they've already using 200 or even 400 gig as access.
Wow. So imagine a server with a 100 gigabit per second connection or network card, or 200 or 400. That's massive, right?
Yeah.
Massive, man. I remember the old days when we used to do only 1 gig.
Yeah, for campus, yes, it's enough. But in data center, there are too many datas.
You're right. Yeah.
Okay, I'll continue this one.
Yes.
In high performance cloud network scenarios, CXN series can play the role as both underlying network and overlay virtualized network. Just as I just introduced, the switches can build leaf spine architecture which is cost effective and scalable. CXN series supports standard layer 2 and layer 3 data center features. They are suitable for building underlay bearing network. When working in overlay, CXN series supports centralized and distributed gateway and enhanced by EVPN multi-homing feature. It has more flexible, high availability options. We also provide AFC to enable a centralized control plane of the network to simplify the network management.
Okay. So AFC, which is Asteria Fabric Controller, is the SDN offering that you guys have to manage that network, right?
Yeah.
Okay.
Yeah, we can use it to directly manage the network, or we can use the API of this controller to integrate with OpenStack, or we can just use a Neutron AFC plugin to manage directly to the devices. It's flexible.
Okay, great. So you have the option, and this is essential. Like if people want to build a private cloud, so you have it ready on the go with that Asteria or AFC controller REST API integration with OpenStack. So you can instantly help with building the fabric needed for that private cloud.
Yeah, exactly. Here, I think here is a question.
Yes.
In compare with VMware access, still a big main difference. Actually, I believe that the VMware, this one is mainly for the how to say, it's more like a host overlay. And in our scenario, is we prefer to do the network overlay and how to say, we prefer to we prefer to build the private cloud to integrate with OpenStack rather than the VMware.
So like the VMware SDN or NSX probably is the oldest one, the oldest SDN offering in the market, and it's based on the underlay overlay over a layer 2 configuration. Today's SDN is like extending further, as Sean just mentioned, and to provide you with that integration with OpenStack, which is a true private cloud. You cannot build a true private cloud with ESX only, or NSX only, sorry, with the NSX only. Okay.
Okay, I will continue this one.
Yes, please.
This is a case deployed in our domestic market. It's a public cloud. They have many resource pools all around China, and in each pool it's built by a 3-layer cloud fabric. In the Tor layer, each pod has 6 pairs of CX308 enabling MC lag for server access, and 4 pieces of CX532 as spine of a single pod. We use 4 pieces of CX564 in the east west interconnection area, which combines all the ports together. CXN switches have standard data center protocols with good performance, which satisfy the spine leaf components requirements of the customer. We also help the customer to understand Sonic-based open operating system, so that now they are already developing their own O&M applications based on their own purpose.
There is a good question here, Sean, that talks about the integration, the integration with OpenStack. So the question from Mr. Bilal is that, is it specific to OpenStack only, or does it work with others such as OpenNebula?
Actually, currently, we've already have the test with OpenStack, and I think there is an OpenStack version with Kubernetes something. And for other platforms, actually everything is done based on the API we provide. So if there is any like specific or individualized requirement, we can help to do the development to integrate with some other platforms.
Yeah. And specifically to add to this, the OpenNebula is easy to integrate with those APIs. So it's not yet tested by the Asterfusion team, but I don't see a reason why it doesn't work. So please go ahead.
Okay. Another important application scenario of CXN is converged enhanced Ethernet solution. As we know, in some HPC scenarios, customers are using Mellanox InfiniBand switches to hold the RDMA protocol. The biggest issue of InfiniBand is that it is too expensive and specialized. CXN it has a minimum 400 nanosecond port-to-port forwarding latency, and by developing data center queues features like PFC, ECN, ETS, and DCBX, it ensures that there will be no packet loss in the HPC network. With smart NICs that supports RoCE protocols, CXN switches can build a RoCE V2 solution. Actually, in our practice, we are mainly using Mellanox CX cards, and we also have a plan to build our own interface card to support RoCE.
Yeah.
This is a case. Sorry.
Yeah, I want to add something here also, Sean. Like if you've done anything related, guys, to convert Ethernet, and you know how it takes how it consumes the buffers, starting from the user space all the way to the network card, including TCP buffer and the IP buffer and others. So Asterfusion also supports the RDMA mode. That is like a genius replacement to that. It really saves you so much, and that's why they have such a great latency on board and capabilities on board. With RDMA as kind of replacement to convert Ethernet, you reduce all of that. You don't even go to the kernel level buffers, which is like the sockets and the IP and all of that. So they do support both the RDMA and convert Ethernet. Yeah.
Yeah, I think here is another question.
Yeah, I think there is another question. Apologies. Yeah. So how to move from network load with 3-tier architecture to open network? Will be network configuration changes impact? Nice question, man.
No, I think I'm not sure if I'm understanding correct that you mean actually in data center the vendors is already using the spine architectures for I think for many years.
Yes.
You mean application level? Sorry, I think I'm not getting it very well.
Let me add something, and if you want, Mr. Abdel Nasser, I can allow you to talk and have a chat. But the move from traditional three-tier architecture, first of all, three-tier architecture is really absolutely old, and it definitely has been deficient and not good for today's network. That's like even big companies such as Cisco, the leaders of the three-tier architecture 15 years ago, they're getting rid of it to start with. The second thing is moving to open networks. It's not a difficult experience. It starts with a decision. If you have a spine leaf architecture already, and you have a spine from any vendor that can go with known protocols, we can have leaves from Asterfusion, and then we can span to the pods below that, and manage, as Sean showed, we manage the whole east-west traffic, and then the north-south traffic goes through the Cisco spine or whatever other spine that you might be having. So you can go granular. Even with legacy applications, it has no impact on that. Let me allow you to talk, Abdel Nasser. Just give me a second. Where is Mr. Abdel Nasser? Abdel Nasser, yeah. You can talk now if you want to unmute yourself and participate.
Yeah. Can you hear me?
Yes, we can hear you.
Yes.
Yeah, I'm talking about the service level of the application. Like we have three-tier, like front end and application and database within layers of network communication. Moving from the old traditional subnetting and to the open network, will it impact, or it's just gonna just move without doing any changes to the application level? Because some application changes to the IP address may impact the business running production.
Nice question. I thought you're talking about the network three-tier architecture, which is core, distribution, and access. But you're talking about the application structure. Unfortunately, actually, what happens is that it's going to enhance the reasons behind that. One, because you have a much lower latency on board. Two, because the network operating system itself, which is in this case, it's AsterNOS, but it's also based on Sonic. And Sonic itself it has a SI layer and it has containers layer, and that architecture of Sonic, we may spend some time on Sonic, Sean, but that architecture of Sonic is truly today the magic stick that you see in clouds. That architecture is truly the that kind with all of the REST API and RESTful API integration. It's a magic stick to applications today, and that's why it gained so much momentum in the public cloud space, because they want that capabilities provided: auto provisioning, zero touch provisioning, low latency, freedom of movement and motion, API integration, and all of that. They wanted that for their applications and multi-tenant applications that they host as a public cloud. It's a major step ahead moving to open networks. Let's go with even the stuff that is related to programmable switches, because with open networks and with Sonic, you will be able to configure these switches the way you want. You can add your own pieces of code. You can create your containers to run specific functions for you. And I've seen companies, I've seen a major player in the voice over IP industry in our region that utilizes open networks through such programming. Remember, this is all at heart is Linux, and on top of it is Sonic that is modular, that's based on container, and it has a SI layer that separates, that gives you that agnostic behavior, and that gives the freedom for applications. It does add major step. It adds a major value to the application integration and application, even with legacy applications. That doesn't make a difference. Sean, I don't know if you want to add anything around that also.
Yeah, I think you've already answered this very well.
Is this good enough for you, Mr. Abdel Nasser?
Yeah, thanks, clear. Thank you.
If we get the chance, we will dig deeper in the sonic architecture, but we'll see how it goes. Yeah, but please proceed, Sean.
Okay. There is another case of a POC with our customer. We proposed three different scales of the networking. If they have 64 nodes, we can use it. We can make it as a single device. They have 128 nodes. We can build it with 6 devices. And if they have 256 nodes, we can build a network with 8 devices. Yeah, we can see the test result of these two different HPC applications. The average speed of CXN Rocky V2 network and the InfiniBand network are almost the same, but the cost of CXN is nearly 50% price less than InfiniBand. And in storage specs performance test, we use CX532 to compare with the InfiniBand switches. And we can see the performance of CXN is even stronger in some conditions. Our campus access switches product line now has 11 models. They can cover most of scenarios like GE access, PoE. Actually, as I just explained in this two POC, we are using Manilux CX6 or 7. I think it's 6. Yeah, because currently in the market there are only Manilux CX cards, and I think it's Intel 810 or 820. These two models support blocking. So we are using these cards for a test, and we are also planning to build our own cards in the future. Yeah. Let me continue. The switches can cover most of the scenarios like GE access, PoE access, 10G fiber access, and if there's any small cabinets. We also have 220 millimeter depth for the compact sized cabinets. They support virtualization features like VXLAN and EVPN for multi-tenant requirement. Also some security features like MACsec, and we can also customize some special processing logics for some individualized customers' requirements. Actually, Asterfusion is the first vendor to bring Sonic into campus network. We also use a leaf-spine cloud architecture to build our campus solution. The scale of the closed network can be as small as less than 200 terminals and 48 wired ports with a single device, or also can be as large as more than 700K users and 147K wired ports with a multi-layer closed network. We use all layer 3 network in campus solution. Each layer of the network is working as a BGP AS, and the broadcast domain is terminated in the access ports. So there is no concern about the broadcast storm and the Ethernet loop. We can use 3 to 5 skills to build a large-scale campus network. Imagine that if we are using big chassis, we need spare parts of different line cards, different backplane cards, different fans, and power modules. Life will be easier in this kind of architecture that we just need to prepare some spare parts of this 3 to 5 SKUs.
Sean, there's a question from Mr. Bilal about the smart network interface cards, the new approach of those network cards that offload the servers through packet processing, like trying to. So he's asking, are you guys manufacturing it? Are you manufacturing smart network interface cards?
Yeah, currently we only have TPU based, and we are planning some RDMA some cards that support RDMA protocols or Rocky protocol.
Okay, so you do have smart cards at the moment, network cards for servers, right?
Yes.
Okay, perfect.
Yeah, and I will introduce later.
Okay, nice, very good. I didn't know that. This is a good achievement. I was about to say no.
Yeah, because last time I only introduced I think our fabric and the cloud fabric and the canvas, and this time I show everything we have and even what we are doing now.
Okay, great. So the answer is yes. Perfect. Please proceed.
Yeah. This one is the campus case. We have a good practice with one of our customer to build a cloud-based network in their campus, in their new campus, as they want to have something different from traditional campus network architecture. We introduced our solution to them. The campus is huge, so we take a 3-layer glass network, and each layer has a campus spine, building spine, and floor spine. By this method, the point-to-point connection has a maximum of 8 hops. You can see 1, 2, 3, 4, 5, 6, 7, 8. Yeah, to reach each other. So the latency of applications is very stable.
Great.
We also had a practice of integrating campus and the data center network together in the same office building. We build campus network normally on the floors, and the data center is built underground. All the pods share the same super spine to facilitate a complete office network, including wired and wireless campus network and data center network. Yeah, besides cloud switches, we also have a product line of packet brokers. The PXT series are developed based on XT bare metal platforms. They can cover the basic functions like packet wildcard matching, packet truncation, and tunnel termination, as well as advanced functions like keyword matching, deduplication, and passive SSL decryption. Maybe this one has not a very big market, so I think not everyone is familiar with this kind of products. We can see that we provide a network visualization solution based on PXT series. Some customers in like financial or telecom industries, they have the requirement of building an independent monitoring network. So the PXT visualization matrix can be the bridge of production network and back-end analysis systems. The matrix can be managed as each single device or working as a cluster by using AFC NPB as a management plan. We have many success stories with many banks in China, and also we are cooperating with our carrier operators.
And this also adds to the question that Mr. Abdel Nasser first started like 10 minutes ago. This is the power of such an operating system. You see it now. And if you allow me, Sean, I want to also say a comment about packet brokers. Packet brokers are gaining momentum now because of cybersecurity. The reason why is because you need to sniff cybersecurity metadata from the network traffic to do network detection and response. You want to see if there is a ROG access point or a dark a dark endpoint in your network that is generating malicious traffic. The only way to detect that is through NDR, network detection and response, and the only way to do that is to sniff that traffic. In the old days, if you guys remember, we used to do spanning ports, like we configure the switch to mirror the traffic to another port, and then we sniff it, and then we have to worry about how many VLANs are there and all of that. But then we get the tabs, if you remember, like Gigamon and Exia, I forgot the names. Remember the aggregation and regeneration and filtering, trying to sniff that. But now packet brokers have taken that visibility to a level that has never been before, way ahead from traditional network tabs. So because of cybersecurity, packet brokers will see a major demand in the coming period, because you need to get that visibility of the traffic, the security metadata of traffic transporting your network, and everywhere you need to see all the traffic, and packet brokers are the best for that. Apologies again, Sean, please.
Thanks for explanation. Yeah, and we also have some white box platforms, XT and ET series. XT series is Intel Tofino-based P4 programmable bare metal platform. They come with ONI and Open Network Linux as operating system. The customers can also install Debian, Stratum, or Sonic community version to define their own products. CX30 comes with two optional Marvell Octane-based ARM Core DPU, which can run some DPDK or VPP applications as an extension. The PXT advanced functions such as SSL decryption are implemented in the DPU modules.
Yeah, imagine the power you get from that, guys. Like even on SD-WAN level, SD-WAN configuration and programming, billing systems, you can have them remotely on small devices. If you have like remote customers and you only need that switch that you can program on top of Linux, you can add your billing system, you can add your SD-WAN functionality and reduce the demand and the bandwidth and all of that. This is major for programming, and lots of research. I do believe research and development companies are using it for testing and for development and enhancement of their products.
Yeah, and actually, this product line is very popular in some universities.
Yes.
Yeah, for research.
Yes, good. Yeah.
And I want to say is someone may already know that Intel has stopped the Tofino line. But yes, but we have customers, very big ISP customers in China. They have about 6K sets per year demanding for us. So we will continue to develop the Tofino series products. Yes.
Okay. So Tofino, that ASIC that comes from Intel. Yeah, because there are different ASICs that Asterfusion uses. One of them is the Tofino ASIC from Intel, and I think this product line uses Tofino, right? The Tofino ASICs.
Yes, Tofino 1, and we have Tofino. Oh, this one, the X3T is Tofino 2.
Okay.
Yes.
Okay. And is this the only product line that uses Tofino?
Yes.
So the others use Trellix and others, right?
Trellix and also Prestera from Marvell.
Okay, perfect.
Yeah.
Yeah, and also PXT. Yeah, actually they are the same hardware.
Okay.
Yeah, and compared to XT, our DPU appliance has ET series and Helium SmartNICs. This one is just I mentioned before is our SmartNIC. They are more like switch or NIC style servers. They are built based on Marvell DPU and they can install standard Linux, run DPDK for some network traffic processing. Here are some proposed solutions for white boxes. For ET series, it can be used as a small branch gateways to hold like SD-WAN or other VPN applications. ET1600 also has a small Wi-Fi module to play the role as a small access point integrated in the gateway. For XT series, we can migrate the multiple gateway functions, such as load balancing or traffic scheduling, into the DPU module using a single piece of hardware to replace the multiple software gateways. This is a scenario that Ivy mentioned that it is one of our biggest customers application scenario. And for SmartNICs, we can do something like OVS offloading or 5G UPF offloading to release the CPU power of the servers.
Okay. So DPU is the data processing units, right? Like the NVIDIA,
Yes.
Bluefield, and others. So you have your own DPUs, right?
Yes.
Oh, okay.
Yeah, actually, DPU or Intel is now using another, how to say, it's calling IPU. It's a very, how to say, new concept that, yeah, CPU, GPU, and DPU will define the world in the future.
Yes, you're right. Yes. There is a question also here from Mr. Bilal. How does the Aster Network Operating System or Aster Sonic differ from the community version? Like, what is the main difference from the community version?
Actually, the difference is that the community version is contributed from many different vendors like Broadcom also contributed a lot, but our CXN and CXM series are mainly built by Marvell, so we do some enhancement work based on Marvell chipset, and we are also cooperating with Marvell to do some work inside level. So this is the main difference from us to the community, and also we have because we have the many customers, they have their requirements, some advanced requirements. So we built some advanced features than community version, such as VPN multi-homing and some features in campus scenario. Yeah, actually, another question I think is about AFC. AFC is more like a general brand of our controllers. Currently, we have 3 AFC. One is for DCN, as I introduced, is mainly for data center networks. It can be integrated with OpenStack. And the AFC MPB is for packet brokers to build a cluster management for the visualization metrics to act as a virtual device. And in campus, we also have our AFC, and later I will introduce it in another slide, I think. Yeah, it is based on open Wi-Fi architecture.
In addition to that, the AsterNOS uses one of the containers that makes the interface exactly a Cisco similar kind of interface. So the same commands and everything that you are used to, especially if you had someone trained in Cisco or you spent money training engineers in CCNA, CCNP, and CCIE, they get the same command interface because of that container. So AsterNOS comes with that already. Yeah.
Yeah. Okay, so this slide is our existing products and solutions. And as I discussed with Mohad earlier this week, I'd like to show something more that what we are doing recently.
Yes.
As our understanding, the market share of Cisco and Huawei is very huge in Middle East, and their customer relationship is very strong, so that they have the chance to participate in the projects in a very early stage. In that case, we may have little chance to win the project. And in our opinion, our strategy is to build some flexible and lightweight solutions to find our suitable end customers.
Yeah. So Sean is gonna share with you the roadmap and thoughts and plans forward for the products. And we need you to hear your feedback, guys, like about this development to be more competitive in the projects that you guys run. Please go ahead, Sean.
Yeah, this slide actually, I used it to do a showcase in a Sonic community event. And we are developing an open Wi-Fi based controller as a brand of campus network. Open Wi-Fi is another project funded by TIP, which stands for Telecom Infra Project, similar to Sonic, but it is focusing on wireless network. They provide cloud controller SDK and develop a standard for wireless access points, hardware, and firmware. Besides that, OLS, the Open LAN switching, is built as a sub-project aims to manage the LAN switches. The architecture is easy to understand that AsterNOS is running on the switches and there is a uCentral client installed inside as a container. It will communicate with the uCentral gateway, which is installing the as a component in the controller for the unified management. Yeah, this is some screenshots of our more of a dashboard of a single switch. We can see some alarm information and interface status and some general statistics. And also we can see syslogs, transfer rate, history of each interface, and neighbor information. We are developing configuration features to achieve a complete ZTP. That means that you can pre-configure the switches in advance in the controller, and there will not be any on-site configuration anymore. That you just need to plug the switch and it will get the configuration from the controller, maybe on the cloud, maybe installed just in your switch. Yeah, when we talk about managed network, you probably think of Cisco DNA, Meraki, or Huawei Cloud Campus. But due to their business strategy, the solution is always very heavy. The customers need to buy servers, and the features provided by the controllers are far more than the customers really want. The point is, the solution we propose is lightweight and it is totally under control of the customers. We are also developing this hardware with 2 CPUs and 2 optional DPU models. One CPU to install AsterNOS, and the other one can be used to run Open Wi-Fi controller. And we can also run software like OpenWRT in CPU or DPU to achieve functions like enterprise gateway or firewall. Yeah, that's all I want to share today. I want to say thanks again to HUD for the efforts, and we are glad to learn more about the Middle East and African market, and to see what we can do and what we can change.
Yeah, if you allow me to add some stuff here, especially with regards to development, guys. So as you have seen, Asterfusion came from the big story, which is the cloud level switches with the best, lowest latency on earth, highest technology, Alibaba and Google and others, going down to the campus switches. And now there is focus on the campus switches and campus wireless. One of the reasons why they want to focus is that they still want to give you the capabilities you get from the power of their network operating system and their SDN controllers, but at a lower price. They want to make sure that at campus level, you will be able to be competitive commercially the same way as you are competitive technically. So that's a roadmap where Asterfusion is going through. Already, Asterfusion has worked on pricing, and they've given special pricing for our region, where you get really good prices for competitive prices, but they're still also working further down the road to make sure that you get even a much stronger commercial position when you position Asterfusion switches. That's one. The second thing, Asterfusion is now one, maybe if two or three manufacturers in the world that can today deliver sometimes in 6 weeks, 6 to 8 weeks. Not many of today's manufacturers of networking equipment can deliver in 6 to 8 weeks. And if the project is not like forecasted or very complex or big, maximum within 4 months, I think, or 3 months, they still can deliver. One of a few, maybe 2 or 3 maximum manufacturers today that can deliver that. Compare it to the 9 months you get from Cisco or 6 months you get from Aruba or stuff like that, which is a major advantage. So what Asterfusion is bringing on the table is a great cloud level technology at the access level for your small even businesses, commercially very feasible and technically very solid, with central management and central features of SDN and controllers, all of that, with simplified architecture, no complexity, no complexity of added virtual machines and servers, network management tools and everything on the switches, programmable switches, capable to do everything. I want to leave it to you, Ivy, a bit also to have your thoughts.
Yes. So thanks all for your time, for attending the sharing meeting with us. And much appreciated, Mahat, for giving us the opportunity to meet your partners and your resellers in the MEA market. As introduced, we are a Chinese open networking turnkey solutions vendor of 1G to 400G white box switches, powered by our self-developed enterprise sonic distribution for cloud data centers, enterprises, and campus access, etc. And as introduced, Asterfusion is actually the primary company in the market that run full-featured and production-ready enterprise sonic on a full series of campus and data center switches. So we aim at providing open, scalable, flexible, high performance, and the most importantly, the cost-effective network solutions to our customers. So Sean also had introduced our open networking solutions and why we need open networking. And some people here may know that Sean, this is the second time that Sean shared our PPT to the MEA market. Yeah, so someone may be already familiar with him. Yeah.
Sean did great training, technical training,
yes.
if you remember.
Yes.
Yes.
So we want to see if anyone has other questions.
Yeah. If you guys have any questions or feedback about the roadmap from Asterfusion, the only thing we ask you for, guys, is like to put us in front of your customers, either to talk to consultants, to your consultants, or talk to end customers, networking team members, wireless team members. And we will blow their minds off with the technology, with the capabilities, with the delivery, with the pricing, with everything. We will put you in a position that truly differentiates you in front of your customers with a great added value from such a great product. If it runs cloud data centers today, imagine how it will work on your campus network or your data centers, local data centers here, with all of the features, end-to-end with SDN capabilities and auto provisioning, configuration management, controllers, everything all in one. You got them from with a very simple architecture, right?
Yes.
Okay.
And I also want to say that we plan to visit Dubai. Yes, I mentioned before. So if you have customers that you want us to visit together with you, we can provide the necessary support for you.
Yeah, we'll be so happy to have you guys. Yeah, so if you guys, so the team will be here in Dubai. We will share the dates of the visit with you later on. And if you want us to meet in person with your customers, we'll be more than happy to arrange that. We will provide you with the updates later.
Yes.
Awesome.
Okay.
Great. So I think if there is no more questions, I think we're ready to conclude the webinar. And again, I really kind of find the words, Ivy and Sean, to thank you for your support and your dedication to help us in this region. I do believe open networking is going to disrupt the region as I see it today. One of the largest telco providers in the region that has never, ever believed in open networking. Today, they have an RFI for open networking. So you can imagine the major mind shift that has happened.
Yes.
It's massive. It's massive. And the value is absolutely clear. It's absolutely clear. You're not locked into a vendor. You have the openness of Sonic. You integrate with applications. You run your own applications. You run your own controllers on top of your network. You don't worry about complexity or maintenance or stuff like that. And finally, you don't even worry about delivery. If you forecast the deal with us, you will get it in 6 weeks. You'll get your network equipment in 6 to 8 weeks maximum. And if not forecasted, maybe 3 months, sorry. Which is still major compared to the most players in the market.
Yes, and yesterday evening, my colleague just got campus switches order from USA. It's 200 sets, and we promised to deliver them in 2 weeks.
Wow.
Yes.
2 weeks. That's mission impossible.
Yes, 2 weeks.
Imagine it's mission impossible to Cisco or Juniper or even Huawei cannot deliver in 2 weeks.
Yeah.
Awesome. Thank you so much, ladies and gentlemen. Looking forward to seeing you again in one of our upcoming webinars and trainings. Thank you so much.